So, many physical quantities, such as speed, can be completely described by a single real number called a scalar. So, can everybody please box the word scalar? This number indicates the magnitude or size. Box magnitude or size. Scalar is a magnitude or size, and also box single real number. When we come back from Christmas, we will talk more about complex and not real numbers. A vector, I'm going to double underline vector, is a quantity that has both, what did vector say in Despicable Me? Magnitude and direction. So a vector is two things, a magnitude and a direction. You do not need your computers open if y'all can close them so they are not a distraction, please. So the velocity of a football is a vector that describes both the speed and the direction of the ball. So, a boat traveling 15 miles per hour. State whether each quantity is describing a vector or a scalar quantity. So a boat traveling 15 miles per hour is a what? Scalar. Why? Because it's just the number. It's just the speed. A hiker walking 25 paces due west. It is a vector because it's both a magnitude and a direction. A parachutist falling straight down for 12.5 miles per hour at 12.5. Down 12 miles per hour is a vector. What questions do I have about determining if something is scalar or a vector? A vector can be represented geometrically by a directed line segment or arrow diagram that shows both magnitude and direction. A vector has an initial point, which is the tail, or the starting point, and a terminal point, which is the head or the tip. And so when we write a vector, we write it must go in that direction. So we're going to have AB with an arrow up top. It kind of looks like a ray that we learned in geometry, right? A vector can also be written, and you're going to see me write it like this, where it just kind of has the top part of the arrow. That's also a vector. So if you just see the top part of the arrow, that's still a vector. What can I not do when I'm naming this vector? I cannot do BA. Why? Because you're flipping the direction. You're saying it starts with B and goes to A, and that's not true. Also, you cannot just leave it with nothing up top or a line up top. If a vector has an initial point at the origin and it is in standard position, we've talked about standard position a lot this year, so meaning it starts at the origin and goes out, then the direction is the angle between the vector and the horizontal line, aka the x-axis. In shipping as well, or in shipping, yeah, I can't think of the right word right now, or in like air traffic control, whenever they deal with what direction or where is the ship going, they do that in vectors. Same thing with air traffic control and airplanes. If you ever notice, they have, when they show airplanes going, they show them going in straight lines, in vectors, and they'll say the airplane is going 80 degrees northeast. The airplane is going 120 degrees northwest. And so they do everything like that with your theta. Okay? Alright, so the length of a line segment represents the magnitude. Magnitude is another word for, does anybody know? Distance. And we are going to represent that with two lines like this. So it kind of looks like absolute value lines. Do y'all agree? But it's two of them, and that just means the distance. And you're also going to hear me say the magnitude. So magnitude and direction, the distance and the direction. So there are three types of vectors we will talk about. Parallel vectors have the same or opposite direction, but not necessarily the same magnitude. So I could have a vector going this way and a vector going that way, but they are not the same length. I could also have a vector going the same way, but not the same length. Equal vectors or equivalent vectors have the same magnitude and direction. And opposite vectors have the same magnitude but opposite directions. Oh, sorry. And technically, I believe, excuse me, these are also parallel, they're considered parallel vectors, but equal vectors and opposite vectors are the better name for them. So what we're going to do next is we are going to represent these vectors geometrically. So when two or more vectors are added, their sum is a singular vector called a resultant. The resultant is like your answer. The resultant vector has the same effect as applying one vector after the other. And geometrically, the resultant can be found either using the triangle method or the parallelogram method. Personally, I prefer the triangle method. To me, the parallelogram method is just more work. So I am not going to use that. However, you can if you want to. I personally will not be doing that. When you add two opposite vectors, the resultant is a zero vector, denoted by vector 0 or just 0. And then if vector v is multiplied by a real number scalar k, the scalar multiple k vector v has a magnitude of k, absolute value of k times the magnitude of v. I know I'm just reading this and you're like, yeah, sure, got it. We're going to get to that on the back, and what I'm reading will be explained. Okay? Are we okay? Alright, so what we have here now are a bunch of given vectors. So I am giving you vector u, vector v, vector w, and vector z. And what we are going to do here is geometrically represent, adding and subtracting these vectors. So I'm going to do it algebraically just to show you, and then I'm going to do it geometrically. Alright? So vectors are represented kind of like an x component and a y component. So here's vector u, and we use chevrons to represent these components. Chevrons, arrows, carrots, whatever you call them. How does vector u move from its initial to its terminal point? How many right? 5 right, and how many up or down? 0. So this is represented as 5, 0. Vector v, how would I represent vector v from its initial point to its terminal point? 4, 2. Do not put parentheses. If you put parentheses, I'm counting it wrong. All right, vector W. Write this down, please. Edwin, why's your computer open? Shut it, please. Nicole, shut your computer, please. W. How would I represent W? 3, -4. Why -4? Because I am going down 4. And I know all of these kind of go to the right, but if they were going to the left, then it would be negative. And then last but not least, Z is not going left or right. 0, and it is going up 5. So 0, 5 is vector Z. Write that down, please. Cassie, you with me? Okay. If I were to add vector U to vector V, what would I get? 9 what? Why 9, 2? Add your x components, add your y components, and do you agree you get 9, 2? That's how you do this algebraically. Now we are going to do this geometrically. You're going to have to be able to do both. So, look up. Do y'all agree vector U goes right, not up or down? Vector V goes right and up. When you are graphing these, you need to figure out where to start. You can start anywhere, but you don't want to start in the middle and then go right and up and then end up off your graph. So before you start, you need to kind of get a gist of where this is going so you don't go off the graph. You also need to make sure you're using pencil. Okay? So since I'm going right twice, I'm going to start pretty far left. And since I'm going up, I'm going to start kind of left and down. Is that okay? And then the way that you do triangle method is I'm going to graph 1, 2, 3, 4, 5, 0. And I'm going to label that vector U. I have my initial point. I have my terminal point. Where vector U ended, where the arrow is, now that's where I'm going to start vector V. So V was 4, 2. I'm going to go right 1, 2, 3, 4, up 2. Do you see how if I would have started any more left, I would be off this page and you would get points off? That is vector V. So wherever you ended with vector U, that's where you start with V. So where your arrow is with vector U, that's where your initial point will be for vector V. Oh, why did I start right there? Because I just started left and down. Because I knew I was going right and up. But what I'm like, could you have started 1 over? Sure, yeah. What if you would have started 2 to the right? You'd be off the page and I'd count points off. Yep. Correct. Now, your resultant, remember how on the front we talked about the resultant? The resultant? Your resultant is you taking your vector U and connecting it to the end of vector V. Use your badge to get a straight line. And this is vector U plus vector V. And hey, what is vector U plus vector V? How far is it? Or how does it move? It goes right 9 and up 2. Isn't that what we said it should do? So we did the first algebraically, now we just geometrically graphed it. What questions do I have? Any questions? All right. I'm going to do the parallelogram just so you can see it. You do not have to do this, but I need everybody to look up. The parallelogram means you start both of them, 1, 2, 3, 4, from the same spot. Vector U will start here, 1, 2, 3, 4. You don't have to do this, 1, 2. Vector V will also start there. And then you do them again, but opposite. Now I'm going to do vector U up here, 1, 2, 3, 4. and then I'm going to do vector v right here, and your resultant would be the diagonal of them. To me, I don't like doing this just because to me it's just the same thing but more work. Does that make sense? So that's why I don't do it. But you could do parallelogram method if you wanted. I'm never going to do this for the rest of these. Okay? Alright. C. It says 2 vector u minus vector z minus vector w. Can we put our heads up? I see a couple people fading. Heads up, look at me. I want you to look at where this is going. If I have 2 vector u's, it's going to go right. Negative vector z. What is negative vector z going to do? It's going to change my values to negative. So instead of going up 5, it would go down. So this is going to go right twice, then down. And then negative vector w. Instead of going this direction, what's it going to do? It's going to come back up. Where should I start this at? I should start it at the left top area. So I'm going to start somewhere right here. And I'm going to do 2 vector u's. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You need to label or I'll count points off. Negative vector z. If I put a negative in front of this z, what does that make this? 0, negative 5, which does what? So from my end point here, I'm now going to go down 1, 2, 3, 4, 5. And you need to label it negative z. Don't forget your vector symbol above that z. Last but not least, we have negative vector w. W is 3, negative 4. If I make that negative, what's going to happen? Negative 3, positive 4. So it'll go left, 1, 2, 3, up, 1, 2, 3, 4. Again, use your badge if you need straight lines. What will be the resultant of this? The starting point to the end point. And where am I going to put the arrow? On the end point. And label that. That is 2 vector u minus vector z minus vector w. And if you want, you can do the math to check it. What's 2 times 5, 0? What's 2 times vector u? 2 times 5, 0. 10, 0. Minus z? 10, negative 5. Minus this? 7. Minus negative 4 is a 1. And so then check. 1, 2, 3, 4, 5, 6, 7. Negative 1. It works. I want you to try D on your own. Go. You try D on your own. Be careful, watch that negative. Is this what you got for vector v and vector negative w? Because remember, it's negative w. Make sure you have that negative. I forgot to put the negative right here. Y'all, nobody corrected me. It needs to have a negative with it. Did you put the negative and just didn't realize I didn't? And then your resultant is going to connect them and put an arrow. And label that. This is vector v minus vector w. That is about as complicated as we are getting with the graphs. There's nothing more to add to that. Do I have any questions? I heard from somebody who has friends at Ridge, they made them graph like 20 of them. Any questions? While y'all finish that, I'm just going to kind of read the back. It says, or the bottom, vector OP in standard position on a rectangular coordinate system can be uniquely described by the coordinates of its terminal point P, xy. We denote OP on the coordinate plane by xy with the chevrons. Notice that x and y are the rectangular components of OP, and we call this component form. So can everybody just... You get component form from your points, which have parentheses. But component form does not have parentheses. Alright, and then also maybe circle the, right here, the x, y, and they are chevrons. Alright, since vectors with the same magnitude and direction are equivalent, many vectors can be represented by the same coordinates. And to find the component form of a vector that is not in standard position, you can use coordinates from the initial and the terminal points. And you would do that by using this formula. Where have we seen this formula before, kind of? Distance formula, slope formula. You've seen it in many different things, right? x2 minus x1, y2 minus y1. So that is how you are going to find them. But be careful. Your initial point must be the ones. Your terminal point must go with the twos. So, do you see how this says AB? This AB tells us, hey, A is initial, B is terminal. So with A is going to be my x1, y1, and B will be x2, y2. I could totally trick you and give you this as BA. Make sure you're reading the instructions. So just plug that in. x2 minus x1, comma, y2 minus, I don't know why I put a comma again, minus y1. What is 3 minus negative 4? 7. What is negative 5 minus 2? And this is vector AB in component form. I want to tell you on your homework, it actually tells you to write it in linear combination form. I could also write this as 7 vector I minus 7 vector J. This is the same thing, just in a different form. We'll learn about that form tomorrow. I would like you to do example B. Go. look up and see if you got the same answer as me. Do I have any questions about, given the points, finding the vector in component form? Make sense? All right, last but not least, what we're doing today is we're finding magnitude. What did I say the word magnitude was? Distance. Magnitude is distance. As a reminder, here is your distance formula. x2 minus x1 squared plus y2 minus y1 squared. If you have points, you're using distance formula. What if I just have the components? Then you can use Pythagorean theorem. You can skip the distance formula. You already have what they are. Use Pythagorean theorem. So for this question right here, to find the distance of vector AB, remember I do the 2 absolute value. I would do x2 minus x1 squared plus y2 minus y1 squared. Write that down, please. Kylie, Ava, write it down, please. Edwin, write it down. Do y'all agree this is the same problem from above? Did y'all notice that? What is 7 squared plus 7 squared? Negative 7 squared. 49 plus 49 is? Square root of 98. And you need to simplify this radical. What is the square root of 98? Isn't it 49 times 2? Which is what? It is 7 root 2. And that is your magnitude or your distance. Questions? Am I going too fast? Do y'all agree these problems are exactly like what we did above? So, do you agree above we discovered that this was negative 9, comma negative 11? So how can I find the distance of this if I know the component form already? Just square both of those and add them together. Does that make sense? So instead of doing distance formula, if you know the component form, just do a squared plus b squared and square root it. And that gives me 81 plus 121, which is 202, which is 101 times 2. I don't think that does anything. Does it? No. So the magnitude is 202, the square root of 202. What questions do I have? Besides graphing, none of this was like super new, right? Alright, you have the rest of the class period. What I'm going to do now is hand you that review homework that is due on Monday when you come back for Thanksgiving. You can do numbers 1 through 10 now. You know how to do 1 through 10. Say again? A total? 26. But y'all can do 1 through 10 already. Tomorrow I'll give you time to do more. By Monday? Yeah. Yeah. I want you to do it on this paper, please. You're turning this paper in on Monday. Alright, you can do 1 through 10 on this paper. Y'all get started and I will finish playing that clip.